Hi everyone, and welcome to this account. Here I will be talking about basics of artificial intelligence, and I think I should probably say a little bit about the structure of the videos and how I want to convey information to y'all. I firstly want to separate big topics into some modules. For example, this one is called Baselines and Basics of Statistics, and each module I will break down into 5 to 10 minutes videos where I will be talking about one specific concept because I feel that I don't know, it's more convenient for me to watch short videos because in today's world I think it's easier for most people. And beginning with this module, firstly, we're gonna talk about statistics, and then we will touch a little bit of machine learning. In statistics, we're gonna talk about mean, mode, median, variance, and standard deviation, and I think I'll also mention the coefficient of variance because it's an important thing from my perspective. We will also talk about machine learning. We'll touch a few basic concepts, but I will mention them briefly because I don't feel like they are important or something, but everybody knows them, I think. And those are what is actually a model, what is targeting, how to fit a model, how to predict with it, what the difference between some neural networks and maybe some linear regression stuff, and we'll also talk about what's the difference between classification models and regression models, and in the end I will send you laboratory work when you will create your first model without understanding, just to feel that it's easier than it seems to be. And we will create two models, our two first models, one for regression and one for classification. Those are really easy. I think everybody would understand that. And the topic of today's video is mean value. And what is that actually? It's written down here that it's actually an average value of a set of numbers. So let's imagine a situation. You have a data set, just like here, like 6 numbers, 1, 2, 3, 4, 5, and 6. And you want to represent your whole data set with just one number. How do you do that? So you don't know how to do that, and mean is actually the thing that will help us. How to get it in Python, and then we will talk about how to get it mathematically, because I feel that this formula may seem complex for a lot of people. So firstly, we need to import numpy as NP. It's a Python script to get the mean value of this explicit data set. You can use it for every kind of a data set that you want, but the thing is that your data set should be a numerical array, because it's obviously impossible to get the mean value of things like apple, orange, and apple juice, something like that. So all of the values from the data set should be numerical. What would we do? We just say import numpy as NP. It's an external library. You can download it with pipe install numpy or pipe3 install numpy if you're on macOS. And no, if you're on macOS, you should probably run pipex install numpy, but whatever the script for installation is, you can just Google it and then you state import numpy as NP. It's one of the most important libraries that we're going to use because it's widely used in AI itself, in statistics, in machine learning, so everywhere. And I have explicitly stated that our dataset is just a 6-number array. It won't be actually that small in most cases, but just to test, I think it's kind of great. What we do here? There's the most important line of code, and here we say that np.mean is the most important function that actually gives us the mean value, what we're talking about. We explicitly state the dataset here, and why did I use the float function? The thing here is kind of tricky and not really important, but I will talk about it. So numpy is a library which is written in C because it's for complex mathematical calculations, and it's for working with large matrices. We will talk what a matrix says a little bit later in the next module, I think. And what was I talking about? I forgot. And then continuing with this numpy thing, because it's written in C, which is much faster than Python, obviously, we will get not just 3.5 as I've stated here, but we will get np.float 3.5, and in order to translate a tricky C float 64, as you remember, to Python version, we just use the float function. So we talked about how the mean value is got in Python, and we're gonna talk about how to calculate that mathematically. With this formula, it might seem tricky, and I feel that the problem with all the math formulas is that they are all tricky when in reality you need to have like more than 30 IQ to understand them. So what does this formula actually say? It says that take the sum of all of the values from this data set from index 1, so from the first value, to the value with the index n. So n is actually the index of the last element of an array, so it represents firstly the number of all of the values in the array and the index of the last number. So how to actually understand that? So mathematically, we start our indexation from the number 1. So we actually say that this is the first index, second, third, etc., and then this is the 6th index. And 6 is actually n, because it's the 6th index and we have 6 values here, so that is what n actually is. So what do? Here we actually just take the sum of all of the values from our data set, obviously from x1 plus 2 plus 3 plus 4 plus 5 plus 6, and then multiply them by 1 and divide it by n, by the number of all of the things in our data set. I'm sorry. And what does it actually mean? It means that we just take all of the values from this data set, summarize them, take the sum of them all, so 1 plus 2 plus 3 plus 4 plus 5 plus 6, and then we divide it by the number of the things in our data set. So in this case, we divide it by 6. So this is the whole mean. It's not a complicated concept. But the next thing is a little bit more complicated, but it's a little bit less important from my perspective, but I think it's worth talking about. So a weighted mean. To dive in as fast as we are able to, just imagine a situation when you are at school and you get 3 marks. 4, 5, and 3. And you got 4 for your test, 5 for your homework, and 3 for, let's say, a final exam. And then your mom comes and asks you, like, son or daughter, what's your average score for this semester? For this class? I don't know. You would probably think, and I would also probably think, that we should just take the mean value of the three things. So we just say 4 plus 5 plus 3 is 12, and we divide it by the number of them, we divide it by 3, so it's 4. But in reality it's not 4, because we have just got 3 for our final exam, which is, to be honest, pretty bad. So for the purpose of saying what values are important, people introduced weights. So they just represent numerically the importance of a certain value from our data set, from our set of numbers. How do you get a weighted mean in Python? Then how do you get it mathematically? In Python, we use another function. Firstly, we use float for the same purpose as we did before. Then we use this np.average function. We state explicitly our dataset with marks, and then we just say that weights equals our dataset with weights, and we would get 3.6875, which is, to be honest, much less than 4, but it's not overall bad. I had even worse marks at school. How it's done mathematically? We see those both signs. You should understand how they work completely, because we will encounter them a lot. But they're actually, in most cases, they just represent the sum of all of the values from whatever this is. Here, in the numerator, we just say that take the sum of the products with each mark, in our case, multiplied by its weight. So 4 multiplied by 1.25, 5 multiplied by 0.75, 3 multiplied by 2. Take the sum of it, and then divide it by the same thing as we talked when we were talking about the mean value. But here, instead of this dataset, we just use this array. So it's the sum of all of the weights. So we divide the sum of products by the sum of weights, and we get a weighted mean. I'm sorry this video was a little bit long, and this is my first video on YouTube. I hope y'all will go to comments and say what was bad about this video, and should I maybe change something, change colors, change the way that I talk to you. And I hope you all enjoyed it, and I hope you will move on with me to more complicated concepts of machine learning and statistics and AI. So stay here. Next video would be much shorter, like 5 to 10 minutes, 5 to 7. I mean. So something like that. Goodbye, y'all, and see you in the next video.